Okay. Nope, that's not what I want. That's...
It says it's live on the corner, so I don't know if that means it's recording already.
I hope so, because I think that's what I did last time. But now it put me on YouTube, and I don't want to be on YouTube. Nope, that's not it. 1 second. Okay, what are you doing?
Oh man.
Ah,
Yeah,
oh,
we had a lot of problems with this like last week. It sucked. I was like, no one could get anyone, and I was just, I don't know why we have to use this Google thing.
yeah,
So weird. Did you do a hangout on air?
yeah, we're on here
It's weird.
and stuff. Okay, I think it's recording.
Okay,
I hope so. If it's not, my bad.
that's fine.
Okay. Um, can you hear me?
Yes. Can you hear me? Can you hear me? Can you hear me now?
Dana, can you hear me?
Yes. Do you see me? Can you hear me? I can hear you.
Can you hear me now?
Yeah, I can hear you.
Okay. I don't know what that was.
It like keeps freezing.
Yeah, I don't know what that is.
Dang it.
Um, okay. I don't know why it did that. Okay, so do you have... Oh, are you serious?
What happened?
Why is it doing this? Okay. Um, it's like I don't... My computer is being really weird. Do you have any questions on the assignment that we did?
Um, for part two?
Yeah.
Yeah, it's just the um what is it called? Like calculate the standard deviation of this discrete random variable, and it's number 6,
Mhm.
the last problem. But like for me, like throughout last week, like me and the two other girls, we like were so confused on how to do the standard deviation. Like we looked it up on Google, we looked it up on the wiki class thing. Like we were like I don't even understand what that means or what it wants us to do. So we didn't even do it, and we got like really bad grades and stuff because it just didn't make sense to us. We're like, how do we find a standard deviation? Like, it just looks so random. So I don't know if you know how to do that or if you can sum it up for me or somehow. I don't know.
Yeah, so the standard deviation is just looking at how far away the numbers are from the mean.
Mhm.
And the way that they did it in the book, it's what they did was they put the number 1 and they subtracted the mean and then squared that answer, and then they multiplied it by the probability of the number.
Okay.
Does that make sense?
Yes.
Um,
Did you do last week's assignment with the companies?
yeah.
Yeah, we were supposed to find the standard deviation for like every single one of those.
Oh, I see. Okay, so on that one, um, it gives it to you, so you don't have to like physically do it yourself. On the, hold on.
Oops. We were doing it, all us three were doing it like all by ourselves.
Oh no.
And we can't do it. It's like there's so much. It would take us 5 hours to do this whole thing on our computers.
Yeah, so do you use SPS or do you use Excel?
Um, Excel.
So I don't know how to do it on Excel, but on the SPSS, whatever crap that he makes us use,
Oh yeah.
you can, hold on, I'm trying to pull it up. Um, let me see. No, not that. No, not that. Um, oops. Hold on. Oh my gosh, computer, why are you being such...
Wait, what are you looking for?
Okay, so I was trying to see if I could do a screenshot of this instead of like, because it's hard to explain.
Uh-huh.
Um, but my computer is super old and it doesn't like me.
Isn't it called like Snippet?
Yeah, my computer is super old though.
No, it's fine. It's okay. You don't have to do that. But I was just like, it's really confusing. I thought we were supposed to do it all by ourselves or something. I don't know.
No, so you just go to
The SPSF thing? I mean, the SPSS.
yeah, and then you go to analyze and do descriptive statistics,
Uh-huh.
and then hit descriptives and make sure you like highlight the one that you want to use, and then it'll all be right there.
Then, oh my gosh, this sucks.
Yeah, I'm so sorry.
And we were just like so depressed because we couldn't get this to start and we couldn't find how to record it, and then we saw what we had to do and it was the worst thing ever. So
I'm so sorry.
it's okay.
I feel like this one, the one we had to do today, is a lot easier.
It did look a lot easier, yeah.
Were you able to figure it out to find the discrete random variable?
Um, for number 6, I
Yeah.
just looked at it and I was like, but for the rest of it, it was fine. It was just that one. It just confuses me when it says standard deviation because then I'm like, okay, you're supposed to square something and I don't even know what that is. So
Yeah. I like the book on how it explained that. I feel like the book and our professor didn't really explain SPSS.
Yeah.
Like,
He was just kind of like, oh, you should get this.
yeah, so it's kind of hard. So I feel like this one, I just used the calculator to find it.
What do you mean the calculator? Like your own calculator?
Yeah, I just used my own calculator to find the standard deviation for number 6.
Can you show me that?
Yeah. So,
Oh my gosh, I cannot find my calculator. This sucks. Oh, I found it. Okay.
so did you get that the mean was 2.5?
Yeah, I don't get how they got that. I thought it was 1.25. Cause
Yeah. So to get the mean, what you do is you go, so the probability of getting it, of rolling any of those numbers is 1 out of 4, And
yeah,
so
4. Okay.
then you go, hold on, I'm trying to, I'm using my calculator on my phone.
Okay.
So then I think you just go 1 out of 4. How did I do that? Just kidding.
So it would be 0.5, but I mean 0.25. Sorry, but it says right there that it's being times by the value, so it's 1.25. But I don't. And then right next to it, it has 2.5. So I was like, how did it get 2.5 from 1.5?
I just did 1 out of 4. Oh, okay. So yeah. So you go 1 out of 1 times 1 out of 4 plus 2 times 1 out of 4 plus 3 times 1 out of 4 times 4 times 1 out of 4.
Oh. Okay.
And then you get 2.5.
Dang, that's a lot of times.
Yeah. Yeah.
Oh, I just came out with a weird answer. This is weird. I don't know, my calculator came up with 0.09 something something, so it's really weird. I don't know what I'm doing wrong. Do I have to do 1 out of 4, or can I just put 0.25?
You could do 0.25, yeah.
Yeah, it keeps coming up with 0.09375. What am I doing? And we're just multiplying, right? Everything's just being multiplied?
No, you're adding each sum up.
Oh my gosh, that's probably why. Plus 0.25 plus 2. Now I got 11.25. Great. I don't know what I'm doing wrong here.
Okay, so are you using the parentheses?
Oh no.
So each, So what I did is I put in parentheses 0.25 times 1 and then add and then another parentheses 0.25 times 2
That's really weird. Okay.
up until 4.
Oh, I got it. Ah!
Yeah.
I need to write this tip down because I'm gonna be like. hmm. Okay, cool.
And then to get the discrete random variable, what you do,
Is you subtract the value with the mean and then square it.
and then multiply by the 0.25.
Okay.
And then you do that all the way till 4.
5 squared times. And then you just add them all up at the end?
You add them all up and then you square that number.
Okay, let me do that real quick. Do we have to put parentheses on like both of those?
Yeah.
Okay. Hmm. Okay then. Let's see. I did it.
Nice. You got the answer?
Yeah.
Yep.
1.25.
Perfect.
Alright, cool. Finally. Alright.
Do you have any other questions for that one?
I think that's it.
Okay, do you want to take the test?
No, but yeah. I'm always so afraid to take those, but I'm like, you gotta do it.
Yeah.
Okay.
Let me know when you're ready.
I think I'm ready.
Okay, here we go. I like that the first two are usually freebies. Makes me happy.
Yeah.
Oh, Okay, come on, computer. That's the sad thing about me taking online classes. I need a new computer.
What kind of computer do you have?
I have a Dell, but it's like from 2000.
Dang.
It's super
Are
old.
you here in Rexburg?
Yeah,
Oh, okay.
yeah.
Dang, that's crazy. Where are you from?
Detroit, Michigan.
Oh, nice. Detroit,
Where are you from?
California.
Ooh,
Yeah, I miss it.
I bet, especially in this crazy weather.
I know, it's pretty crazy today. Okay. Did you get on already?
Yeah.
Okay. So for number 3,
You?
are we gonna do that together or should we just?
Yeah, yeah, let's get together. Okay, well, first it needs to add up. See if it adds up.
What do you mean add up? Are you just gonna add the proposition numbers?
Yeah.
Oh, okay. It adds up to 1.
Is it even? One even?
Yeah.
Perfect. Then it does.
So it's true?
It's true.
Oh. I was like, I don't know.
Oh yeah. Yeah, as long it just needs to add up to 1.
Oh, okay. That's good. Sweet. Okay. What is the probability that a random selected person in the US has type 0, blood? Round to 2 decimal places. So we would have to go back to the proposition thing.
Mhm.
What does that mean, though? How do we find the probability of that?
So shoot. Where's my screen? Okay. So in order to find the probability, I think it's just I'm trying to remember. I'm always bad at this. Okay, so yeah, so it's that. So it's the number they give us over. So it's the number that they give us over the possible answer, or the possible, like, what am I trying to say? So it's like 0.45 divided by the 100.
Oh, okay.
Like it's 0.45. I think.
Hmm.
Let me see. I would say, isn't it 0.45? Um,
Just 45 then? I mean, just 0.45 then? Like,
is
percentage
that
wise?
what you think? I can't remember if it's like 0.45 over 100, like that decimal, or do you think it's just 0.45?
I thought it was just 0.45 because then that would be like 45 percentage of the population or something.
Okay, I'm
Maybe.
really bad at like making things harder than it really is. So, okay, so let's go with that.
Just 0.45 then?
Yeah.
Alright, we'll see what we get. So what is the probability that a random select person will not have type type O blood? So that would be the rest of them added up, right?
Yeah.
O04. That's what it is.
Wait, isn't it 1 minus 0.45? Like 0.55?
Would it be? That's what I did at first too. I was like, I subtracted it because I was like, I don't know.
I think it is. I think it's 1 minus the 0.45.
Okay, then let's go with that then. So it'd be 0.55 then for 4.
Yeah. Yeah.
But then for the next one, so we add them up and then subtract them by 1?
Oh, sorry. No, for number 4, it's 0.45. And then for number 5, it's 0.55.
Oh, okay. I was like, whoops. Oh, yeah, because it says how many would not have that type. I'm like thinking, okay.
Carolyn Wood and their colleagues conducted a study in which dogs were trained to detect bladder cancer. Dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tango, one of the dogs, demonstrates the identification of a specimen. 7 vials containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from bladder cancer patients? Round the answer to... So there's 7 people, and then 1 out of the 7 has cancer. So wouldn't it just be that 1 divided by 7?
Yeah, that would make sense.
Round the answer to 3 decimal places. So
it'd be
point
0.143.
Yeah. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. Very unlikely that a dog would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs can detect. What do you think for number 7?
In a combined 54 trials, dogs correctly identified the specimen from cancer patients 20 times. So the 54 trials, each person had cancer, and only 22 dogs. And only 22 dogs knew that.
Mm-hmm.
I don't know. That's like less than half. So I feel like I don't know. I think it's the second one. Like, there's little evidence that dogs can detect bladder cancer.
Okay.
But I'm not even sure. I'm like, I don't even know if that.
I feel like what they said is contradictory. Like, because it said there's 54 trials, and then the dogs did it 22 times, but then they said it's very unlikely that they would do this. So I'm like, let's just go with the little evidence.
Okay.
What
I'm good
happened?
with that.
M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is in this table. If you reach into a bag of plain M&Ms, what is the probability of drawing a red colored candy? Is that the 0.13?
Yeah. But shouldn't it be all kind of like whatchamacallit. Wouldn't we just have to like add them all up? It's kind of like taking the mean, right? And then dividing them to see how much it would be? Or should we just go with the proposition of it? Do you get it? I don't know.
Oh, I see what you mean. Like, I think it's. Oh, cheaters. So wouldn't it be like 1 out of 6?
Yeah.
I agree with you.
Because, like, if you add them all up, like, oh crap, what did I just do? 84, 100 minus. I don't know, because I'm confused about that. 1 out of 6 equals 0.16. So, because it says if we get red, it'd be like a 13% chance, but if we get blue, that'd be a 24% chance. But it's not equally distributed by color in each one. They kind of just throw in a few, don't they?
Yeah.
So that's why I'm like, should we put 0.13 or should we put 0.17? Because that's what 1 out of 6 is.
Hmm.
Well, I guess. What do you think?
I think it. Uh, I think it would be the 1 out of 6, which means I think our not one out, yeah, 1 out of 6. I think it's 1 out of 6, which means I think number 3 that or not number 3, number 4.
Mm-hmm.
Do you think that should be 1 out of 4?
Oh, that's true. Dang it.
Oh, I don't like this.
That's true. That's true that it should be like that. But you know what I just thought about?
Yeah.
Isn't like the well, it says here that B is like only like 11% point for number 3. It says like the blood types because not every like it's so like some blood types are kind of rare. And so it's like you can't just put up 4 people and be like, one of you has this type blood type, one of you has this blood type, one of you has this blood type, because it's not true. They most likely all have like a blood type O or blood type A because it's so common.
Mm.
And so then I think we're right on that one. But then again for number 8, I think it would be 13, just because it says that the previously indicated, I mean, the M&M website said that the distribution of the colors in the bag are like this. So it's like this is kind of like what they go off of, just like a few colors of each, but
Mm-hmm.
they just happen to get more of blues and orange, maybe because the color is cheaper or whatever. So you know what I mean?
Mm-hmm.
So I kind of thought about that just now because like it's like more rare and stuff. I don't know. So I think it would be 13, but at the same time, it's like, is it really that easy? Is number 8 that easy? Because it does seem like it.
Hold on 1 second. Because I just realized, where is it? Let's see. I'm gonna look at something really quick.
Okay.
Oh no, it's not here. It's in my email.
Oh. Oh.
Okay, so I remembered that I did the homework,
Mhm.
and they ask questions like that,
Oh, okay.
like what is the probability?
Okay.
Um, and the answer is just what number they give you.
Oh, all right. That's good.
So then we're right. So it's 13. It's 0.13.
Yay.
Okay. So
I
what's
did.
the probability of getting green?
I
So,
put it 0.16 because I like added all of them up and then I subtracted it by 100 and then I think and then
so you said 16?
yeah.
0.16? Okay, that's what I got too. And then not getting green, 1 minus 0.16. So just the 84? The
Yeah.
0.84? Okay. Okay. And then this cool graph. Half of the observations are less than or equal to one number. I don't understand that question.
Yeah, I'm like
Half the observations. Are you saying the mean? No, because they gave us the mean.
um well, I guess that could be like the mean, yeah, like 24.3 because it's either equal to the mean or it's less than the mean. Oh no, there's 35. Just kidding, that one's bigger.
But it says half of the observations.
Oh crap.
I don't understand what that means.
Why do you do this?
I know.
Half the observations are less than or equal to what number? It says review. What does that mean, review? Is that on our thing? Let's see.
No, I don't know what review is either.
Dang it. Why do you do this to us? Based on the information on the table above, the top 25% of students scored above what number?
Top 25.
Minimum, medium, maximum. So I guess the maximum is 35, so they scored above 35, or
Or would it be, oof, 27?
what does Q1 and Q3 stand for?
That's the quartile?
Dude, don't do that, that's scary.
I was gonna scream that you were.
Yeah. Yeah.
I think it's 27.
Why? What?
Because I'm thinking from the, when you do it on the box plot using the quartiles,
Shh, sit down.
the third quartile is the bigger one,
Mm-hmm.
but I don't know.
I'm ready to
Because I
guess.
feel like the maximum and the minimum are the outliers. So no one really, like one person may have gotten those numbers.
Oh, okay, yeah, that makes sense.
space
So you want to put 27 for
for
12?
number 12.
Is it just 27, or do we put point 27?
27.
Okay.
But I don't know about this. I don't even know what this means. Number 11.
To the following statements is not one of probability. Let's just do 13 and we can come back to 12.
Yeah. Okay. Which of the following is not one of the rules? Fraudulent outcome will not occur as many results. Number 3. That's not a rule.
Okay.
Okay, stupid 11.
Half the observations are less than or equal to what number? So, I feel like we should add them all up or something. I don't know if that will. Variance, minimum, maximum, interquartile range.
I think you're right.
Yeah, but then after we add them up, what do we do? That's where I would get lost right there.
Oh.
7, 45 plus 5 equals. It equals, all of them add up together is 174.2. And then I just divided it by 9 because that's how many digits there are, and it's 19.35 or 36, whatever. But I'm just still confused. I'm like, I don't know what that has to do with
Yeah.
it. So it's like, I don't know.
Let's see. I think it's the. I'm Googling it.
Uh-huh. No, that's fine. That's good.
And I think it's the. I think we need to find the median,
Oh, okay.
which is just what you did.
I thought I found the mean. Oh, crap.
Oh, that might be it. Yeah. Okay, so I think it's the median.
So, let's see.
14 plus 22 plus 24 plus. Okay.
7. So the median would be 22.
Yeah. Ugh.
So then, what then? Should we just put 22?
Oh, you know what? They gave us the median. They gave it to us 24.
Okay.
Should we go with that? I don't know. I've never even heard this before. It's nothing. I was looking at our book and they don't even talk about that.
Alright. I guess we could just put whatever. I mean, like, I don't think we're going to get a bad grade if we just guess on one.
Okay.
So should we just put 24 then?
Yeah.
Okay.
Ah! I'm so nervous.
Why?
I hate tests.
Yeah, well, it's only like, it's not that long, so it's not that bad.
Yeah.
So,
Okay. Are you ready to submit it?
yeah, I don't think we'd get the answer right away, would we?
I think we'll get our grade, but it won't tell us which one we got wrong.
Dang it. Alright, I'm submitting. Oh, I got an A!
Oh, yes. Which one? The one we got wrong is the one we weren't even expecting to get wrong.
I know!
That's funny.
Dang it, those dogs. We got that one wrong with the dogs.
Yeah.
Oh well. Now we know. Oh my gosh, I'm so excited. Like, I'm so bad with numbers, and just to get this right and understand for once is amazing.
Yeah. Awesome. I'm so happy.
Yes, yes. Okay. So now that we're done, we're meeting again Thursday, right?
Yeah. Do
Okay.
you want to do 4 still or 5?
I'm fine with whatever. I only have one class on Thursdays, so I'm good to do whenever you want to.
Okay. Maybe let's do 5.
I'm okay. That's good. 5 it is.
Okay. See you at 5 on Thursday.
Woohoo! All right. Thank you so much.
Okay.
Bye.
Let's get this saved.
Oh, of course.
Okay. Bye.
Oh wait, are you posting this online?
Yes, I'm
Oh.
going to see if it saves.
Okay. All right.
Okay.
Thanks.